confirm that you are able to hear me clearly? Can somebody confirm that you can hear me clearly?
Yes, sir.
Okay. Well, welcome to this particular session. For the next about 45 minutes or so, I will be talking on specific big data tools, namely Hadoop and Spark. The idea is to give you the background about why such tools are necessary and also walk you through some examples. Also walk you through some examples to show how these tools can be operated and how, using your current skill sets, you can use these tools. So let me begin by sharing my screen. So just give me a minute. I hope you are able to see my screen. Can somebody please confirm?
Yes, sir.
Okay, great. Now, if you have any questions, you can probably put them on the chat window. If they are very relevant, I'll take them as and when they come up. Otherwise, towards the end, we'll have time for about 10 minutes or so of question and answers, right? But I would suggest that as and when the questions come, maybe you can just type it onto the chat window, so it becomes easier for everyone. They'll get recorded and we can visit them at the appropriate moment. Okay. So just to ensure that I have a good understanding of the people attending this particular class, can you quickly type on the chat window to let me know if you have worked on any of these tools earlier? You can just type yes or no. A quick response from you. The question is, have you worked on any of these tools, Hadoop and Spark? Okay, Vidhi has responded. I'll wait for a few seconds to see more responses. Okay, most people are saying no at this point in time. Okay, fine, fair enough, right? So I thought it was good to start off with some kind of background to why these tools, even before we look at the how part of it, right? So let me go ahead. Let me start with this particular chart here, which shows you the amount of internet traffic over the years, right? So till the early 2000s, the total internet traffic was negligible, and internet got introduced the world over, and simultaneously in India in the mid 1990s, and for a long period it was only active in educational institutions and certain companies. But post 2000, as you can see here, especially after 2005 or so, the amount of data that is flowing through the internet has become phenomenal, right? And it has grown exponentially, to say the least. Now the question is, who's creating this data and what is this data consisting of? Okay. So, it is we who create this data. We as in we humans, the equipment that is operated by us, devices, cell phones, machines in your homes, on the shop floor, sensors, various kind of sensors, which are in operation in factories, homes, even for measuring quantities like temperature, pressure, so on and so forth, right? I mean, we are talking about Internet of Things these days, which is nothing but a collection of devices or signal generating agents which are active 24/7 throughout the world, right? And they generate a lot of data. So the exponentially increasing graph that you see is produced by us as well as these devices, right? So when we talk about data, we are creating more of data each day. And for many people and for many companies, this data is like a treasure. And it hides a lot of information about us, about situations, what we are going to do next, what are our likes, dislikes, what kind of company we keep, when are the machines on the shop floor going to break down, is there going to be a cyclone. All of this information is hidden in the data that is generated by the devices, and also the messages that we exchange between ourselves, right? So a lot of people are interested in processing this data. Okay. Now, this data is of many kinds, right? We talk about structured data and unstructured data. Not only that, some of this data is transient in nature. Unless you capture it and store it, it will evaporate, it will go away. It exists for only a small period of time. Other data such as, the purchase data, that for things that you purchase on e-commerce sites, or the tickets that you book, airline tickets, movie tickets, this kind of data is more static in nature. I mean, it gets created and it is resident in some database. Whereas, sensor data is more transient. It comes and it goes. Okay. But we are interested in all of this data. And we would like to process this data. First of all, we would like to store this data, and we would like to process this data and extract intelligence from it. So these days we talk about machine learning and artificial intelligence. And, it is nothing but data which drives all of this, right? If there was no data, there would be no machine learning, especially machine learning. Okay. So the new products and services based on machine learning, based on artificial intelligence that you see are almost entirely based on data and availability of data, right? So data is very critical. Okay. And we talk about analytics. So what is analytics? Analytics is a systematic way of computing this data, or churning this data, and coming out with information which results from this systematic analysis. Analytics also means discovery and communication of meaningful patterns in the data, right? So questions like, if I spend, let us say, X lakh of rupees on advertisement, how much are going to be the sales? So this is based on some patterns, and we would like to draw useful conclusions. Essentially, if you take medical data, for instance, if you process X-rays, then you would like to come to some conclusion about whether the person is suffering from any kind of disease or not suffering from any kind of disease. So that is all about drawing the conclusion. So you have data, you subject it to various kinds of analytics, right? And these days we talk about data science, which actually is a combination of multiple branches. The main ones you see here, you have mathematics and statistics in one circle, computer science, knowledge of computer science in another, and most importantly, the business or domain knowledge. Okay. These three have come together into the emerging field, or field that has already emerged, and which we call as data science. And needless to say, data is crucial or critical for data science, right? So let us understand the data explosion, what it means, before we really look at the tools. Okay. So we saw that graph, and if you go back to the early 1990s, the data was like this. Everything was predictable, everything was manageable, and it was like a coconut. You break open a coconut and you are very sure about what will emerge from the coconut. Okay. Nothing was unpredictable, so everything was under control, right? And today the situation is like this. It's like almost like a dam bursting, uncontrolled flow of data. And the characteristics of the data today is that it flows continuously, whether you like it or not. You have absolutely no prior knowledge about the content. But all that you know is that the content is very rich in information, and you would like to extract that information from the data that is continuously flowing. In many sense, it is unpredictable. You don't even know what is it that you are going to find out if you start processing the data, and seemingly unmanageable. I think somebody's microphone is on. Can I request the IT people to? Okay, thank you. This data is seemingly unmanageable, as you can see this in this image. How do you contain this particular data? Okay, so if you look at the two extremes, prior to 1990s, everything was calm and quiet, and today everything is more or less chaotic, and these throws up some challenges, right? So today's data is characterized by, let us say, the volume of data that is available. It is huge. Companies like Google, Facebook, Microsoft, Amazon, Flipkart, all these companies deal with terrific amounts of data, hundreds and thousands of terabytes, yottabytes, zettabytes, and so on. Okay, let us call it infinite data almost. The second thing is data is getting generated at an ever increasing rate. So the velocity, data has a velocity, and that velocity is increasing day by day. More and more data is getting created. And then of course there is variety, right? So today we have data that could be text, that could be alphanumerical, structured, unstructured, audio, video, comments, blogs, tweets. It takes so many forms, different forms. Whereas earlier it used to be, just in the form of tables, right? So earlier data was very simple. Today's data is very complex. There is a variety of data that is getting generated, and we are creating it continuously. We share the data. Okay, so data today is characterized by these three attributes: huge volume, huge velocity, and wide variety. And all this taken together is what we call as big data, right? So this is the classical definition of big data. And now many people have defined many more V's, but we'll not get into that. So these were the fundamental three V's based on which big data was defined long back. Okay. So what is the nature of modern data? First of all, it is unstructured, right? There is no structure to most of the data. In fact, almost all the data that we generate takes the form of text, audio, video, which either we create or we share. And there is no structure to it. It's not like a table where you can say that column number 1 is the name of a person. Column number 2 is the age of the person. Column number 3 is, let us say, the income of a person, and so on. That would be structured data. Okay, data as it is stored in, let us say, tools like Excel or RDBMS, relational database management systems. By and large, that data is structured, but today's data that we have to deal with is unstructured. It is very large, as we have seen, dynamic and rapidly increasing, highly dispersed. Data is getting generated all over the world. Probably there is no corner of the world where people are not moving around with cell phones or sensors or devices. So, today it is a norm rather than exception that data is getting generated in all corners of the world or all places of the world. Okay, given such a situation, where do you store that data? How do you store it? And for reasons of limitations imposed by physics, we all know that information cannot travel at speed greater than the speed of light. Okay, so even if you want to copy all data that is generated at all places to one central place, that's an impossibility, because studies have shown that the data that is generated in one day will take a few years to be copied to a single location. Okay, that is the kind of data that we are generating today. So essentially what this means is that data has to be stored in a distributed manner, right? It is impossible to move data to a single or central location. Okay. But given all these challenges, we still have to process data and generate results in real time, right? So for instance, when you go for, when you are browsing e-commerce websites, based on your keywords, the e-commerce websites have to generate the recommendations real time and guide you in the purchase process. They can't say that we have too much data to process. You do your browsing and tomorrow we'll give you the recommendation. No, that doesn't work, right? So the point here is data is of different kinds. It flows very highly at a very high rate, continuously getting generated all over the world. It contains a lot of information. These are the challenges. But then the bigger and the most important challenge is how do we process all this data and generate results in real time, right? So the big data questions are how to store, how to process, how to query, right? Where do you store all this data? Obviously, you need hardware to store all this data. So we have to use inexpensive hardware. How to make all this scalable, right? We are talking about data getting created at ever increasing rates. So cost is very important. So how to do all this at reasonable cost, how to store at reasonable cost, how to process at reasonable cost, and how to make it fault tolerant, how to ensure that data that you have captured doesn't get lost. Okay. So these are some of the questions which come up in the context of big data, and the tools that we are going to discuss shortly, they contain solutions to all these problems, right? So this is just to show you the contrast between the earlier ways of doing things or earlier nature of data and today's nature of data, right? Earlier data was quiet, today it is chaotic. It could be accommodated on floppy disks and hard disk drives. Today we have huge data centers. What you see towards your right is the data center involving hundreds and thousands of computers, right? And lastly, earlier data used to be very ordered. This is what we call as structured data. And today it's a chaotic jumble of all kinds of data, which we call as unstructured data. Okay. So as you can imagine, when you have data flowing like this, the first thing you would like to do is to contain it, right? You want to essentially build a dam where you can store almost infinite amount of data. And the capacity of such storage systems should increase over a period of time, right? And that exactly is what is done by this tool called as Hadoop, Apache Hadoop. Actually, the tool is free because it belongs to the Open Software Foundation, and anybody can download and install Apache Hadoop. But of course, when people use it in companies, they would like to have support, and you have companies which provide paid support for Hadoop and some of these other tools, right? So in order to store big data, you need a tool that can handle all the complexities, okay? Huge volume, huge velocity, and variety. All three have to be handled by the tool, right? So if you go back and think about it a little bit, can you store all this data in the equivalent of something like Microsoft Excel? Obviously not. Okay. How do you store audio, video, images? Tools like Excel or RDBMS are not the best way to store such data. So that's where data like Apache Hadoop come to help you and help us to store that kind of data. Now, once you have stored the data, you would like to churn that data, right? You would like to process that data on a continuous basis in order to extract gems of information from it, right? So storage is the first step, and following storage, processing that data is the next step. Okay, and this is where you have tools like Apache Spark coming into play. So the combination of, let us say, Apache Hadoop and Apache Spark, there are many more tools, and I'll show you a slide with which just gives you a bird's eye view of how many tools are available. But at the very minimum, you would like some tool to store huge amounts of data, and you would like a tool to process that data in real time. Okay. We'll also talk a little bit about another tool called as Hive, which also helps you process the data, but in a rather batch mode. Okay, not immediate. But essentially, these are the two steps: storage of the data, and then processing of the data to extract information from it. And the two major tools that we'll be talking about are Apache Hadoop and Apache Spark, right? Now, just to give you one little bit of idea about how data is making a difference, if you take any company and its operations, for instance, probably today there is no place where data and tools based on data, particularly machine learning, they are not making a difference. Okay, data is being used and ML is being used in practically all operational areas of an enterprise. And at a personal level also, we can do so many things if we can handle data and if we can process that data and extract intelligence from it. Right? You can manage your own investments, you can monitor your health, you can monitor your automobile, you can monitor machines that you may own to detect early if there are any problems that are going to happen. Okay, so that is just to emphasize the importance of data. And data is practically not only enterprises, but if you take any of these other fields, whether it is medical, remote sensing, geographical information systems, environment, agriculture, risk assessment, web traffic prediction, traffic prediction in general, image processing, engineering, speech processing. I mean, there's probably no area that is not impacted by data these days, right? So with this background, let me quickly get into how and where to store all this data, right? So we have already talked about Hadoop as a tool for storing big data. Okay. And I've already shown you this figure, which is nothing but a very small section of a data center. Now, these racks that you are seeing here are nothing but computers. I mean, computers in the sense, they do not have an associated monitor, keyboard, mouse, or anything. They are just cards which are connected to the entire system through network, right? So when we talk about Gmail or Facebook or any other application that we use, those applications run on machines in the data centers like this, and we don't even care many a times where those things run. Okay, so it would be good to understand, what is there behind, these kind of deployments. Okay, so let me quickly jump into explaining to you Hadoop very briefly, right? So let us treat Hadoop as a box over here, and I will call this as Hadoop. I will call this as Hadoop, and basically there are two parts to it. Okay, the lower portion has to deal with storage, and the upper portion has to deal with processing of data. Okay, and the storage is known as Hadoop Distributed File System, HDFS, right? Now, what is Hadoop? Hadoop is nothing but software. Okay, and what is software? It consists of a number of programs that collaborate with each other. Programs that collaborate with each other. And then finally, provide you with these two services. First service is allow you to store data, and the second service is allow you to process the data. Okay. So this is a very high level view of Hadoop, and we will not get deeper into this. So now my thing is, if I am here and I have a huge amount of data available with me, okay, I would like to transfer this data first of all into this storage, right? And this Hadoop, for all you know, is in a data center and far away from you. It could even be housed in the same building where your company is, or in many cases it is there in a data center which is hosted by one of these big companies, and it could be hundreds of kilometers away, right? So you have, let us say, your own computer on which this data is residing, and you would like to transfer it to Hadoop. This is just one of the use cases. Okay. So I would like to show this whole thing with the help of an example. Okay. So I have, let us say I have stock market data with, which contains about, 4 years of data. 4 years of stock market data, right? And this runs into lakhs of lines of information. Okay. Now you can be sure that you cannot, or you will not be able to open this kind of data in a tool like Excel, or you might even find it difficult to not accommodate but process the data using relational database management systems. Okay. So let me quickly show you how I have a computer over here on which this is nothing but this computer that I'm talking about, and I have access to a Hadoop system. Okay, I have access to a Hadoop system which could be anywhere on this planet. I do not care, right? And I have a piece of data here. I have a piece of data here which is about 164 MB in size. I have purposely chosen a smaller data size over here. And now I would like to transfer this data into Hadoop. Okay. So I have already installed, I already have access to the Hadoop system. So I give a command like this, Hadoop file system. So this is, I'm talking to the Hadoop distributed file system. I say copy from local. Okay. And the name of the file that I want to, actually before that, Hadoop FS, I want to make a directory in which I want to store this data for. Okay. So this is a command which I am sending to Hadoop. And as you can see, it takes some time. Okay. Then I say Hadoop FS, show me a listing of the directory that has been created. Okay. So now you see that the input directory has got created. I want to now copy the data file that I have into this input directory. So I say Hadoop FS, copy from local all.csv to the input directory. Okay. So it will take some time. The file is slightly big. I would not say, by no means it is big data, but for the purpose of this demo, it is fine. So I say Hadoop fs-ls. I want to see what is there in the input directory. Okay. Now I am using the command line. There are tools which give you a graphical user interface, but in this domain, mostly people use the command line to get all their operations done. So now, as you can see here, what has happened is that in HDFS, I have created a directory called as input, and inside that input directory, this file all.csv has got created. Okay. So this file all.csv, which was lying outside here, has now been pushed into the Hadoop distributed file system, right? This contains stock market data. Okay, so let me show you what this data looks like so that you have some appreciation. So I will say, I'm just opening the local. Okay, so this is the opening price, closing price for various dates for various companies. And what is the size of the data? If I go to the last line, as you can see here, it is 18,94,296 lines of information is there in this particular data file. Okay, so that's how much big the data is, right? Now what do I do? Now that I have the data present here, I want to process this data, right? So how to process? Okay. So what happens is, as part of big data processing, you have, so let me draw Hadoop over here again. So I say this is Hadoop. And tools have got developed over and above this, right? And one of the tool is known as Hive, which is meant for processing, tabular data or tabular data. Okay. So now what I will do is I will read this particular all.csv file that I have created into Hive and then run some queries on top of this. Okay, and these queries are in SQL-like language, structured query language, right? So let me show you how to do that. Okay, so I go back here. I start the program called as Hive. Okay, and now Hive requires Hadoop to be running in the background because one of the sources from which Hive picks up the data is Hadoop. Okay. Now, mind you, these tools are meant for processing huge amounts of data. So what is Hadoop? Actually, Hadoop runs on a cluster of computers. Okay. So Hadoop may be installed on a cluster of, let us say, 12 computers or 100 computers or 1,000 computers. It all depends on how much data you want to process, right? And these tools spare you from worrying about the size of the data. Okay. So the data that I have copied into Hadoop, I will now import into my Hive. Okay. So I have already created the commands here so that we don't waste any time. Right. So what I will do first is I will, now that I am inside Hive, I will first of all describe the data to Hive. So I am creating a data table called as NSE data. And as you can see here, all the various columns have been described. Okay, so I am creating a table in Hive. So let me do that. So again, just to remind you, I am using Hive to process the data that is stored in Hadoop. Okay. So since it was the first time creating the table, it took some time, finite amount of time. So it took 15 seconds, right? So I can say show tables now. And I get a list of tables that exist. And this is the table that we have created just now, which is NSE data. Okay. Now I want to read data into this particular table. So I have the command over here. I take this command line, and now this is an example of how data stored in Hadoop has been loaded into Hive. Okay, so you see this term HDFS here. So this is telling Hive that the data is actually stored in Hadoop distributed file system, and the name of the data is all.csv. and everything else in between is the name of the machine and the directories under which that data is located. Okay, so those are the matter of details. Essentially, what we have done is we have taken the data that is stored in Hadoop and loaded into this tool called as Hive. Okay, now I can say describe NSE data. Okay, NSE data is a table, and as you can see here, it gives me a list of all the columns in that particular table and the kind of data that they are containing. You know, symbol is string, series is string, open, high, low, close. These are all numbers, floating point numbers, and so on. Right. Now, once I have done this, I can actually now very simply, start processing this data. So I can, for instance, find out totally how many lines of or how many records are there in this particular database. We already know that it is of the order of 18 lakhs, right? So let me do it using SQL. So I say select count. I'm interested in the count of the number of records from NSE data. Okay. So basically take the whole table NSE data and give me a count of the number of records in that particular table. So now Hive, takes the data, it spreads it across to the multiple computers that are there in the background. And as you can see, it gives me back that particular number. And I know that this is correct because I had just seen the number of records present in the database. Okay. One simple command to achieve that, right? Now, I want to process the data for a particular company. Let us say I'm interested in the data that is related to TCS, and that too from the year 2011. Okay. So I want to see how many such entries are there for TCS. Again, it is getting processed, and it tells me that there are about 248 entries for TCS. Okay, let me create a separate table just to contain that data, right? So I create this table called as TCS over here. Now, as you can see, it took hardly any time to create this particular table. Now, if I say show tables, I should see two tables. One NSE data and the other one is TCS. I have just created the table, but it does not contain any data as of now. So let me populate that table with the relevant data. Okay. So those of you who know SQL will immediately understand what I'm doing here. I'm asking Hive to write into the table TCS by selecting the name of the stock, that is TCS, the closing price and the date. And I'm specifying certain condition where the year is 2011 and the company name is TCS, right? So once I press enter over here, okay, so it has written the data into the TCS table. How do I know that? I say select count star from TCS. Okay, so I should get 248, which is what I get, right? And now I'm free to, get other information, useful information from this. Like, for instance, let me select this last line over here, Control C. Okay, I want to select the calculate, find out the maximum, the minimum and the average closing price and the total number of entries in TCS. So let me execute this. And as you can see here, this is the minimum value. This is the maximum value. This is the minimum value. This is the average. And these are the number of, entries into the in TCS. This is the one. This is the line that you have over here. Okay. So Hive is a tool which you just saw, where the tool allows you to process the data that is stored in Hadoop, and Hadoop itself is a tool which is used for storing huge amounts of data. Okay. Now, where do all these things fit in? Let us understand, right? Let us take a look at this particular diagram over here. And let me focus your attention on just the right hand side part. Okay. By the way, all of these other tools also form what we call as the Hadoop ecosystem. And they are used for fetching data into Hadoop, taking data out of Hadoop, and so on. And even on the right side, our focus so far or will be on just these three tools. So we already have seen, in a very small way, how data can be pushed into Hadoop, and having pushed data into Hadoop, how it can be processed using Hive. Okay. Now, if you see this, Hive is positioned under this box, which is known as batch processing. Okay. So Hive is not a very fast tool. It has its limitations. Of course, it can deal with huge amounts of data, but it takes its own sweet time. So Hive is used for, let us say, overnight processing, processing of data which is not very urgent. You don't need the data as it is getting generated. For generating reports, for generating analytics, Hive is a great tool, especially when you have semi-structured or structured data. Okay. Now, this other box that you see here, which is real-time processing. Now, many a times we are interested in processing the data as it gets generated. One good example is, suppose you are processing stock market data. You would not like to wait till the end of the day. As and when the stocks move up and down, you may want to process that data and take certain decisions about buying, selling, holding, and so on. So Spark is a tool that is used for such activity. Okay. Now, what I'm going to show you is a very small application using Spark, where again the TCS data will be processed. And this time, the goal will be to fit a machine learning routine, a simple machine learning routine that is linear regression on the opening and the closing price of TCS stock, and try to see if based on the opening price can we predict the closing price. Okay. Again, Spark, as you can see, resides on top of Hadoop. Although Spark can also operate independently, but it makes sense many a times to store the data in Hadoop and process it using Spark. Okay. So that is what we are going to do now. So I have a quick application over here, which is again ready, right? And this environment is the Python Jupyter notebook running Python, and this code is written in Python. So I will quickly run through each of these cells, and you will see the data as it gets generated. Okay. So first of all, we make connection to Spark, which is done. We import all the required libraries, which is also done. We do some initialization of Spark, which takes quite some time because Spark is a huge software, and it takes some finite amount of time to connect to it. Now, while that is happening, let me quickly check if there are any questions on the chat window. None so far. Okay, so that now initialization has happened. Now I initiate this session. Okay, and I now start the process of reading data into Spark, right? As a first step, now if you recollect, what we did in Hive was we created a table. So similarly in Spark, we create a table over here, and then into that table, we read the data from this file all.csv. Okay. So that data is being read now. It has been read. Now let me run. Now these are all Spark functions. Okay. And just like I did it on Hive, I'm going to find out the count of number of records that are there in this particular file. Okay. It does take quite some time because this is the first time, and the data has to be pre-processed and then maintained and then executed. But here you see the results, 18,93,059. Okay. And now that we have the data into Spark, what we are going to do is we are going to isolate the data related to TCS from the year 2011, the same thing that we did in the Hive tool. And we are interested in the opening price as well as the closing price, right? So we create a table, we did that, and now we see what the table looks like. It basically consists of two columns, the opening price and the closing price. So internally, what Spark has done is it has created this table with just two columns. This is the opening price and this is the closing price. Okay. So what we are going to do is check if these two are correlated. Okay. And then we will do linear regression to see if the closing price is a function of the opening price. Okay. And our goal will be to, so if this is the relationship between opening and closing price, our goal will be to see if we can fit a line like this, where this is the opening price and this is the closing price, so that, given certain opening price, we should be able to predict what is going to be the closing price. And you can build your own strategy like this for, doing trading on the stock exchange. So I will quickly walk you through the steps that will show all this in action. Okay. So we print out the first 5 lines of the data. So here you get the first. We find out the correlation between opening and the closing price. Okay, because a linear regression makes sense only if the correlation is decently good. So we have almost 0.95 as the correlation. 1 is the maximum. So this correlation seems to be good enough, right? And now I go about preparing the data for running linear regression. Okay, we will skip these details because this is creating and preparing the data to be presented to Spark in a particular way, right? And I come to this particular cell where we start the linear regression process. I fit the linear regression model. Okay. Now this may look very simple. Okay. But what I would like you to understand and appreciate is that Spark is a tool which will help you to solve these problems as simply as it looks here. Even if you have, let us say, 100 million lines of data to be processed. Okay. The method of dealing with Spark will not change. The same program will work there, even if the data size is really very large. And that power that Spark gets is because of the multiple machines, which is called as a cluster on which Spark is involved. So unlike when you and I work with a computer, we work with just one computer at a time, whereas tools like Hadoop and Spark have behind them potentially hundreds or even thousands or 10,000s of computers working simultaneously. So one huge chunk of data is broken down into smaller chunks, and then each smaller chunk is processed simultaneously, which speeds up the entire process, right? So, in line number 19 over here, I just fit the linear regression model, and it happened, within a second or two. It will take the same amount of time, whether the data is small or it is consisting of hundreds and thousands of records or millions of records or tens of millions of records. That is the beauty of these tools. Okay. Of course, you have those many computers working in the background, but that's the whole thing. managing those computers, dividing work among those computers, getting back the partially finished information, combining it into one final result. All that is done by these tools like Hive and Spark that you are seeing here. So now that the linear regression is done, I will print out some results. Okay, so those of you who are familiar with linear regression will identify these parameters. So we printed out the coefficients. Now this is actually the same as the correlation coefficient that we calculated earlier. And then you have the intercepts and then some additional statistical information that you get to show how good the results are. Okay, now in this particular case, the results are fairly good, right? And now once I have the model, I can do the prediction. So now I am in a position to predict the closing date, closing price at the just by getting the opening price. Now the advantage here is the stock market opens at around 9:15, 9:30 in the morning. And based on the opening price, you will be able to predict what is going to be the closing price at 3:30 in the afternoon. And then you can place your orders and hope to make some money, right? So, you know, as an individual, I can build such models and use it to my advantage. Okay, now I want to see things, you know, as a graph, right? So I go into graphics mode, extract some of the data, and then I do a plot. Okay, between the opening price and the closing price. And you know, this particular graph shows you the actual data versus the predicted data. So the actual data are the blue dots and the predicted data are the red dots that you can see. So you know, our initial assumption has been validated. Our initial assumption was that there is a linear relationship between the closing price and the opening price of TCS, at least in the year 2011. And we have created a linear regression model. And now we can use this red line to predict what is going to be the closing data. You know, so I'll just copy this graph and just show you how it can be done. Okay, so I come here and let me copy this over here. Right. So now that I have a model, what do? I will say that, okay, what if, so today morning I observed that the opening price was 1100. So I create a line like this and I create a line like this. Okay, and I get to know that the closing price is going to be, as it appears, slightly less than 1100. Of course, you are going to get the exact value over here. And based on this, I can probably place an order and hope to make some money. Okay, so this is how I have used the data. Now, you know, considering the size of the data and all that, you may not be able to do this in conventional tools like Excel or even our relational database management system, especially if the data size is very, very large and the calculations are a bit complex. But tools like Spark and Hadoop allow you to do precisely that thing. Okay. So those are about those two tools. So coming back to this, you know, we have seen those two tools, and I would like to go back to this particular chart over here. Let me go back a few slides. Right now, in addition to Hadoop and Hive and Spark, you see so many other tools which have got developed. Like one is known as Scoop, the other one is known as Flume. There are other tools called as Kafka and so many other things, Nifa and so on, right? And it's a whole exciting new world out there, which is allowing people and companies to process the data that is constantly getting created on the internet and make sense out of that data and use it for useful purposes. And you know, these days also there is a tendency to misuse these capabilities. by generating fake videos and things like that. So we have to be on guard against that. But these are some of the tools which are really available and which help you work with big data, really large amounts of data. Okay, so this is where I would like to stop. And if there are any questions based on this brief exposure to big data tools, we can take those questions. So are there any questions? Okay, no questions at all?
No.
Fine. So Ishmit, I think we are done with the session. Do you have any final things to tell the people?